All right, so yes, the warm-up involved converses, so just to lead us into today's lesson, what are converses? We studied those earlier. How do you make a converse of an if-then statement? Converse of an if-then. How many have a memory? You got 3 people? Come on, converse. What is it? Michael. If Q then P. So how would you do that? How would you apply that to number 1? What would number 1 say when you do a converse? Why don't you use this one up here?
If B or if A plus B or B plus B, then A to B.
You did switch it correctly. So you're taking the then part and making it into the if. So it's changing the order that the information is. Are converses always true? No. Even if the original statement's true, when you switch it around, it might make it false. It might still make it true, just depends upon what that statement is. So we're going to be switching the order of information today. So we're going to take the theorems and postulates that we had yesterday or whatever day it was that we were together last. Probably was Tuesday. We're going to take those postulates and theorems and reverse the order of the information and see what happens. So let's see, that's what this is about. Summarizing what I just said. It's not always true because you're switching the order that things happen. So let's take a look at one that's in your notes. Find the actual corresponding angle postulate. It was probably in section 3.2, corresponding angle postulate. What is the hypothesis? What do you have to use the corresponding angle postulate?
2 parallel lines cut by a transversal.
Okay. 2 parallel lines cut by a transversal. That's what you have to have. And what do you end up with? Right. Okay. So the parallel lines is the hypothesis. The conclusion would be the angle's congruent. So if we're going to try and look at the converse today, what would the converse be? If what, then what? Even just looking at what we identified here, what would the converse be like? Kenneth?
If the corresponding angles are two parallel lines.
Right. And the 2 parallel or 2 lines cut by a transversal, they'll actually kind of put that in the beginning to make it sound right, but this is what she said. If corresponding angles are congruent, then the lines cut by the transversal are parallel. So you start with the angles being congruent, and you end up with lines that are parallel. Let's see if it's true or not. Okay, we're going to do a little quick experiment. So on like the back of one of your papers there, is that protractor, or we don't? We're going to try and draw some, use our measuring and create some angles that are congruent. Okay, we're going to try and draw a picture. So we're going to use a compass and straight edge. Actually, we're going to use the protractor. We're going to draw, not just construct. Okay, so let's start with a line, actually 2 lines intersecting. So on your paper, with a straight edge, draw 2 intersecting lines. I don't really care what angle they're at. We will use our protractor to try and duplicate that angle. Later on, we'll actually construct it, but for right now, to explore, we're just going to use, doesn't have a protractor.
Well, this one has.
We pulled some protractors out one time.
Yes, there's-
No, this one has.
I can put one in there and have it ready. All right. All right, chill out. All right, measure the angle. Measure the angle that you just created. Okay, measure it accurately. Don't round it. Measured? Is yours the same as mine? Wow, that's creepy. That is creepy. I thought that was an 8 for each. Okay, what we're gonna try and do then is make another angle that's that same degree measure, like higher or lower or left or right. I think I'll go up on it. And see if we make another angle, a corresponding angle that's that same degree, do we end up with lines parallel? So to do this, if you're gonna go up, let's put a point on that segment, or that line that's going up. Now you want to measure from here down, however many degrees it's set. So I'm gonna turn my protractor this direction, and I wanna measure that angle that's coming down to be the very same degrees as the angle that I created. Why is it right there? Well, because I'm going to connect and make that angle in its corresponding spot. So I made this angle 53 degrees, just like that one. Have to put it in the correct spot. So from the transversal coming down is where I was putting my corresponding angles. This is the angle I measured. This is the one I created. Oh, yeah. Put a dot on here. And you want this angle. Try to make it equal. So you know where to put your protractor to measure to create where you located it. Okay, a lot of you understood what I was doing? Okay, what we need to look at then is, the question is, when we made these corresponding angles congruent, did it result in parallel lines? Does it appear that your lines are parallel? Does it appear mine are parallel? Some of you are saying I put the angle in the wrong spot, so it's not working. Okay. That should have created congruent, or excuse me, parallel lines. So that converse was the converse of what postulate? Which one did we start with? Corresponding angles postulate. So this is the converse of the corresponding angle postulate that we just experimented with. And some of you were good at the experiment, others it didn't work out. So the wording for the theorem, if two coplanar lines, now notice it just says they're on the same plane, it doesn't say they're parallel. You don't start with parallels. If two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, that's the hypothesis. So the hypothesis I tried to highlight, it's that angle 1 and 2 are congruent is the hypothesis. I don't know if you want the picture or if that mixes you up. So if angle 1 and angle 2 are congruent, then the conclusion is the two lines are parallel. If you're drawing that picture, make sure you do not put parallel markings on the lines. The hypothesis is not that they're parallel. The conclusion is that they're parallel. Students seem to always get mixed up because the converse or the original. You look at what the hypothesis is. The hypothesis for this, you have to have the angles congruent. Yes, on Tuesday we had to have parallel lines. All right, so I think, have I emphasized enough the difference? The original theorem had the parallel lines as the hypothesis. The converse has the parallel lines as the conclusion. And the reverse is true for the angles. It's the conclusion there, hypothesis here. So it switches the order that things happen. What do you start with is maybe what to always focus on. Okay, we're going to use that in order to do some explanations. You might call them kind of doing a proof. So how can we get from knowing that measure of angle 1 equals measure of angle 3 to the fact that L and M are parallel in this picture? What are you given? What about 1 and 3? The measures are equal. Okay? So first you would write down the measure of angle 1 equals measure of angle 3. We're going to make these look like a 2-column. Although instead of me writing line 1, I'm just kind of doing it line by line just because I was trying to squeeze it in. What can you come up with if you know that measure of angle 1 equals measure of angle 3? Okay? Okay, not their measures are congruent, just the angles. And do you know what would support that? Very good. Okay, so you can get angle 1 congruent to angle 3, definition of congruent angles. 1 and 3 in the picture are corresponding angles. So right now we have 2 corresponding angles that are congruent. That's our hypothesis. What can we conclude? Picture converse. If you have the corresponding angles congruent, what can we come up with as a conclusion for our next step? What's the then part saying, Molly? L and M are parallel because of?
The converse of the corresponding angles.
Very good. Okay. So this is a little like 3-line, 2-column proof. You're going to be setting up things like that on your homework as far as the solution to the problems. Some of them are real short. Some are even just 2 lines. This was 3. There are some that take a little bit more. We'll do a few more examples. But that's what you're going to be doing to show that the lines are parallel. Okay? Question on that one. Why did we have to go from line 1 to 2? Why couldn't we just go from 1 to 3? Well, what's the hypothesis of this converse say? Doesn't it say the corresponding angles are congruent? So you've got to get them congruent. You can't just have them have equal measure. So that's why that step had to be in between. All right, got what you want, note takers? Let's try another one. Okay, notice this one has different given information. Says that angle 3 is that equation, measure of angle 7 is that one, and x is 30. So how would we go about doing this one to try and get the lines parallel? Let's start calling that stuff given. What do you think we would do? Do we know how big angle 3 is? Kind of. It says x is 30. Why don't we put 30 in there for x and see what happens? What's it called when you put the 30 in? Substitution. So I'm going to do substitution property. Let's substitute into the measure of angle 3 and the measure of angle 7. Are you with me on what I did? And I actually simplified it. Maybe I should have made that a separate line. But I substituted in and calculated. So measure of angle 3 is 40 degrees. Measure of angle 7 is 40 degrees also. They're both 40. So wouldn't that mean that they're equal? So if I'm gonna show you that measure of angle 3 equals measure of angle 7, what am I gonna support it by? What's gonna support that? Measure of angle 3 is 40 degrees. Measure of angle 7 is 40 degrees. I want to say measure of angle 3 equals measure of angle 7. That's substitution. Substitution property of equality. We're taking out a 40 degree and putting the other name of the angle that's equal to 40 degree in its place. Now it's kind of like the last problem that we had. So what did we do next? Reason? Correct. Get that congruent angle part. Then let's look at the picture. Angle 3 and angle 7, are those corresponding angles? Yes, we now have them congruent, so what can we do for the last line, Zach?
The L and M parallel,
Because
the converse, like, congruent angle, the
Corresponding.
and
Yep, other C word. Converse of corresponding angle postulate. Okay? So there's a little bit longer proof because of what was given. That would make sense? A lot of you got stuck on how you would support this. The substitution, because what we're doing is taking out the 40 and putting the name of the other angle that's equal to 40 in its place. All right. Those two were just on the corresponding angle converse. Let's actually try and construct those lines. We used a protractor for our little experiment. Let's see if we can get it to work with constructing. So on your paper, did I give you a space in your notes? I did. And I've got the line slanted and the point off to the right. Okay, so instead of going up, we're going to create one to the side. Okay, there's a point here. Okay, what we're going to try and end up with is a parallel that goes right through line P, or point P. We're going to try and end up with that in here. In order to do this, we need to create a transversal. The transversal needs to go through point P. I don't care what its slant is, really. Draw a line, goes through that line and point P, give you some space off to the right-hand side. If the pencils get way too short, there are some more in the basket here. Now, instead of measuring the angle, we're going to construct the angle. And if my parallel's over here, I'm just going to kind of show you. If we end up with the parallel going through here, wouldn't this angle be corresponding to this angle? So what I'm going to try and do is copy that angle over here so that I know accurately where to put what I dashed here. I'm going to get rid of those so that you don't get confused, but that's what we're going to do. Make that angle over here. Copying an angle with your compass and straight edge, put the point of the compass on the vertex of the angle that you made when you drew your transversal. Draw an arc that goes through each side of the angle and do that same arc from point P. Have it kind of go in about the same position as the first one. Use a protractor if you're constructing. Get those two arcs so that they match. This angle and get it over at point P also. Now, the important thing about angles, remember, is how wide it is. So those arcs are so that now we can do the kind of measuring or setting how wide it needs to be. Ready for me to take you that next step? If you remember how to copy angles, you should be good here. So I'm going to put the point of my compass where that arc intersects one side of the angle and open and close my compass so that when I make a mark, and you do need to make a mark, the two arcs have to cross right on that ray. That's where your sharpened pencil really helps. They have to cross right on that ray, otherwise it's not quite accurate. Once you get that width established, now you're gonna mark on the arc for point P's angle. So go to where the arc crosses the side and make a small arc that crosses that first arc that you had. That tells how wide angle P needs to be. Connect point P and that X, and if you did it accurately, you will end up with a line parallel to the one you started with. Look like it worked? You always have to put the point of your compass at a designated point. You just can't randomly put it. So like you have to probably extend that out before you can really mark how wide it is. You have to have the arc and the side crossing, otherwise there's no definite point to use. Got that same width, how wide it needs to be. Okay, give me a thumbs up or down if that worked for you. Did it work? All right, looks like pretty good. Now, how do we know that that is a parallel? You could do some measuring to verify. There's what's called the parallel postulate that supports it, right down at the bottom of the page there. The parallel postulate says through a point P that's not on a line, there is exactly one line parallel to line L. So it's saying if you have a line and a point, there is one parallel that you can make, exactly one. So if it's positioned correctly, it would be parallel. Why can't there be more than one? Well, it has to go through that point, it has to be parallel to this line. So what would happen if I would tip it a little bit? Yeah, it's going to intersect, it wouldn't be parallel. What if I slide it one way or the other? It's not going through point P. So through that point, compared to the line that you have, there's only one parallel, but there is such a parallel. That's why we could construct it. So that all kind of ties together. All right, let's look at the other converses. The next three converses, if you flip your page there, these are theorems instead of postulates. What's the difference? Theorems you can prove. Theorems you can prove. Postulates you can't prove, you accept it as proof. I don't think anyone really was questioning if you get these angles the same, the lines will be slanted the same amount. I don't think anyone really questioned that. You can use the corresponding angle converse to prove these three converses. Okay, so running down through them, remember they're the reverse order from what we did on Tuesday. So the converse of the alternate interior angle theorem starts with the angles congruent. So it says if two coplanar lines are cut by a transversal so that a pair of alternate interior angles are congruent. So in this picture, which you're writing your notes on, angle 1 and 2 are alternate interior angles. If they are congruent, then what's the conclusion? The two lines are parallel is the conclusion. Converse of alternate exterior angle theorem. Again, the hypothesis is going to be the specific angles congruent. If it gets kind of low, you might open your book to section 3.3. This was all together on one screen. So on the converse of alternate exterior angle theorem, the hypothesis part is you have alternate exterior angles congruent. Conclusion, the lines are parallel. The third one looks a little bit different because it deals with the same side interior angles. And what was the relationship for same side interior angles? supplementary. So that one reads a little bit different. If two coplanar lines are cut by a transversal so that a pair of same-side interior angles are supplementary, then the two lines are parallel. How will you know if they're supplementary? What's that mean? They add up to 180. So if those two angles add up to 180, you could call them supplementary, and then you can use that converse. You cannot go directly from the equation that they add up to 180 to use this theorem. There's a step in between there, because this converse says they have to be stated as supplementary. So the examples that we look at now won't be just one set type. It's not corresponding angles all the time. There'll be a little mixture here. So we'll have to figure out which converse is it. What's the conclusion of these converses? Say again, Ted. The lines are parallel. So you're using these when you're trying to support two lines being parallel. Why does it seem like I keep saying that over and over and over? The students don't remember it. So I'm trying to emphasize it enough for you to remember it. Does anyone still need the screen? Okay, so let's have you try to name the theorem. Why don't you pair up with, let's go front row, back row. 1, 2, and then these two, and you guys can pair up again. 1, 2, 3, 4. Okay, so first row turn around and talk to the second row, third turn around and talk to the fourth. Discuss these four answers.
Okay. So I think number one would be the converse of the alternate interior angles. And then 2 and 7 would be the converse of alternate exterior angles. 3 would be converse of the corresponding angles. 5 would be same side interior. And then
Okay, Brianna, what'd your group give for number one? Correct. Number 2, Brendan. What about it? Definition, theorem, converse theorem, what? Converse. Converse proves or concludes that the lines are parallel. Okay, how about number 3 with angle 3 congruent to angle 7? John?
The converse of corresponding angles.
Yes, I think that was the postulate. I don't get real picky about that part, but I do get picky as if the converse or not, because those are definitely different. And how about number 4, with 3 and 5 being supplementary? Nathan? Correct. All right, let's try a little bit more of that, like showing or proving, but we got more choices than what we had earlier in class. Okay, we want to show that R and S are parallel, and we're given that angle 4 is congruent to angle 8. 4 is congruent to angle 8, we're supposed to get to R being parallel to S. We have to write down every step. What's probably the first step? Yeah. Angle 4 congruent to angle 8, given. Do we have something we need, or do we have to do something with it? 4 and 8 on the picture look like alternate exterior angles. They're congruent. So if the alternate exterior angles are congruent, what can we conclude? The lines are parallel because of? Correct. Converse of alternate exterior angle theorem. That one was just 2 lines. What you're given, and really you're finished after just one extra thought. Okay, this one is a little bit more. So write this one down on your paper for an example. Probably have to show the picture especially angles 2 and 3 in the picture. So what are the steps you would need to go through in order to get R and S parallel? First statement. Everybody got an idea what's the first thing to put down? No? I would put all that given information. Right? So I'm gonna just kind of simplify it and put the word given beside it. So here's gonna be my first line. Measure of angle 2 is 10x plus 8. Measure of angle 3 is 25x minus 3. X equals 5. All of that's given. If it works better for you to actually make the 2 column and number them, go ahead and do that. Like I said, I just tried to squeeze things on here so I didn't get all of that in it. Maybe I should go back and do that, but I didn't for today. Okay, so after that given is stated, then what should we do? What did we do on an earlier example? Plug in X. Okay, and plug in formally would be stated as substitution property of equality. Okay, so put that 5 in there for angle 2's measure and angle 3's measure. Figure out what they equal. Write that down, Ryan? Now, when you're doing calculations with equals, it is measure of. So put a 5 in, and what's measure of angle 2? Calculate to be 58. How about measure of angle 3? 25 times 5, 25 minus 3, 122. Okay. Now, last time we substituted, they were the same. They're not the same. Notice anything about those numbers, though? Okay, if you add them together, you're going to get 180, which is going to show up as supplements. So can we say they're supplementary? Not yet. We've got to add them together. So you would put a line in here with the addition property of equality. Add those 2 left sides and right sides. What are we going to get? It's going to say measure of angle 2 plus measure of angle 3 equals 58 plus 122. I showed that so you can see what I'm adding. What do I get when I simplify? Measure of angle 2 plus measure of angle 3 equals 180 degrees. What does that indicate? What can they be called? They add up to 180. They can be called not linear pair necessarily. You have to know what they look like. Supplementary though. Okay, so the next line, call them supplementary. Angle 2 and angle 3 are supplementary. I abbreviated there. Definition of supplementary angles. Why do we have to have that? Well, if you look at the picture, aren't angles 2 and 3 same side interior angles? And the Converse we're working on says if the same side interior angles are supplementary, then the lines are parallel, so we had to say supplementary. So now we did. What's our next line? R is parallel to S. Reason. Converse of same side interior angle. Get the idea how you'll do line by line? So when it says like show, it really means prove. So give me a thumbs up or down if you understood that one. Okay, all right, looks like we're doing reasonable. Ready for another example? Okay, let's skip that one. You did pretty good. On this one, when you substitute, notice they end up the same. So do you remember what we did after they were the same? You didn't add together, you substituted together. And then stated them congruent and got our converse to the parallel part. So that one was a little bit different. This one's a real proof, okay? So let's do at least one real proof together before you start on some homework. Okay, so write down what you're given, what you're trying to prove, get the diagram, and let's see what thoughts we can put together. I'll write it up on the board here so that you can see the information at the same time. Two-column flow chart. Two-column, you want to go? I'll go with that. Statements, reason. Yeah, I would write it in your notes so you have something to look at. Okay. We are given P and R parallel. Given angle 1 congruent to angle 3. What can we come up with from P and R being parallel? This line is parallel to this one. We had theorems that said if two parallel lines are cut by a transversal, then certain angles are related in a certain way. So what angles, based on the numbers that they provided us, they usually number the ones that they think we would use. So if we have these angles, how about angle 2 and 3? What kind of angles are those based upon those parallel lines? Ignore this part of the picture.
Alternate exterior.
Alternate exterior. So what did that theorem say about alternate exterior angles? If the lines are parallel, then alternate exterior angles are congruent. So I'm going to make a note up here. We'll be able to get angle 2 congruent to angle 3. How are we going to get L parallel to M? Switch colors. To get this line parallel to this one, this way, angle 3 is probably not going to help us. Angle 1 and 2, they're corresponding. So if we can get them congruent, then the converse will make these lines parallel. Okay, from this and this, can I come up with angle 1 congruent to angle 2 in some way? What's going through your mind? What's a possibility? Transitive is what it's going to be. Transitive property of congruence, not substitution. You can only substitute with equalities. It would help if this were in the other order, wouldn't it? Didn't we need it maybe angle 3 congruent to angle 2 so that the angle 3 connects our ideas? So when we write it down, let's not write it that way, let's write it this way so that then we can get angle 1 congruent to angle 2 by transitive. Okay? All right, so line 1, let's go with P is parallel to R, that was given. What did we come up with from that? Angle 3 was congruent to angle 2. What was our reason? Alternate exterior angle theorem, not the converse, the original one. Okay, then let's put in angle 1 congruent to angle 3. Where did I get that?
Given.
It was given. And we said out of those two, we can come up with, if we use them in the right order, angle 1 congruent to angle 2 because of the transitive property of congruence. And I'm going to make a note, we used line 3 and then 2, just to help you follow it. And once we know angle 1 congruent to 2, you told me those are corresponding angles. So that can get us L parallel to M by the converse of the corresponding angles posture. There is a proof. Did you follow it? Thumbs up or down? Followed it? some ideas on actually how your proof would go. So as you work through these, you're arranging a lot of things in two columns. Some of them are calculation type. That one was more just an actual geometry. Let's get a start on some problems. Page 166. And I said Monday we would do a quiz. So that quiz is over sections 3.1, 2, 3, and 5. Here's some suggested problems. Suggested problems. I don't want you to pack up and put things away, so I'll come around and get the supplies, but get started on this first problem so that I can see that you're progressing okay. Start in on that first problem and see if you can put together on your own. I want to put your name on it. Before the basket is.